Is flying plane is a related rate problem. Let's read the problem first. A plane flying horizontally at an altitude of 1 mile and at a speed of 500 miles per hour passes directly over a radar station. Find the rate at which the distance from the plane to the station is increasing when it is 2 miles away from the station. So first step is we have to draw a diagram. All right, so let's draw a diagram. So this one is altitude of 1 mile, right? So this is altitude. Altitude means the height. So we draw a height, and then this is 1 mile. And then a plane is flying horizontally. So horizontally means it's moving forward. And then at a speed of 500 miles per hour. Okay. Passes directly over a radar station. So that means this is my radar station. And then find the rate at which the distance from the plane to the station. So the distance between the plane to the station is this. So basically we get a triangle, right? So let's label the picture. So first one is altitude of 1 mile. So this is 1 mile. So we draw 1 mile. And then we have a radar. What else? So for the rest, I am going to label the pictures right here. So the first thing that I want to define is the time. So I'm going to let t be the time in hour. All right. And then I'm going to label this as x. So what is x? X is the horizontal distance. Traveled by the plane. Travel by the plane. And then I also have a y. What is y? Y is the distance from the plane to the radar station. So y is equals to the distance from the plane to the radar or to the station. So now the picture is labeled, and where is my plane? My plane is right here. So this is my plane. All right, what else is missing? So I use the 1, I use the horizontal distance, the distance between the plane and the radar, and then I define the horizontal distance. I haven't do anything for the 2 yet, for the 500 and the 2. So what is 500? 500 is the speed of the plane. So that is 500 miles per hour. Do we write 500 miles per hour equals to the speed? No, that is not how we do it. The 500 miles per hour is the rate of change of the horizontal distance right here. So that means instead of writing the rate, this is what we do. We don't use the word rate. How do you express the word rate using derivative? We call this a dx dt is equals to 500 miles per hour. This is a strategy you have learned in related rate. All right, you have to use the appropriate notation. We don't use the word rate. And then what is the problem asking? The problem is asking what is the distance. It's not the what is the distance. Find the rate at which the distance. Rate at which the distance. So the question is looking for dy dt. The rate of change of y with respect to t. That is the distance between the plane and the radar station. So what is this? And then what about the 2? When it is 2 miles away from the station. So when the distance between the airplane and the radar is 2 miles, when y is equals to 2. So that is the problem, what the problem is asking. So what type of triangle is this? So we have 1 mile altitude. That tells me this is a right triangle. So when you use a right triangle, what theorem do you use? What is the relationship between the three sides? The relationship is you have x squared plus the square 1 square equals to y squared. This is called Pythagorean theorem. So Pythagorean theorem. And then how do we find the dy dt? The rate of change of y with respect to time. We have to use implicit differentiation. So use implicit differentiation. To differentiate the equation we have right here. So we are taking the derivative of x with respect to t. All right, so we have dx dt, right? So the derivative of x squared is, we have 2x. So what is the variable? The variable is time. So we have to do a dx dt. And then the derivative of 1 is equals to 0. And then the derivative of 2 is 2y. So we treat y as a variable anyway, but we are doing this with respect to t. All right, the time is changing. So dy and then dt. Okay, so the implicit differentiation is done. And then the next step is you plug in everything you know. All right, so we have 2. Do we know what x is? No, we don't. We don't know what x is. So we have a 2. We have a 2x then. And then dx dt. Do we know dx dt? Yes, we do. So we have 500. And then 0 is 0. And then dy dt, so we have y equals to 2, so 2 times y, and then we don't know dy dt. Can we solve for the unknown? The answer is not yet, because we are not able to solve one equation with 2 unknown. So at this point, we are one step closer to the solution, but we have to figure out x. Oh, by the way, this is no longer y. I just said y is equals to 2, so that is equals to a 2. So to find the x, we have to recall the right triangle that we just draw. So this is 1. We don't know what x is, but we know y is equals to 2. So when y equals to 2, at that moment, you have to tell me what x is. So we have 1 squared plus x squared equals to 2 squared. So x squared is equals to 4 minus 1 equals to 3. So x is equals to square root of 3. And then we plug in the square root of 3 to x, and then we solve for dy dt. So we have 2 times root 3 times 500 equals to 2 times 2, and then dy dt. So the y is equals to 2. So we only have one unknown. We can go ahead and solve it. So we have 2 root 3 times 500 divided by 2 times 2. And then that is equals to dy dt. All right. So this one, what is dy dt equals to? So dy dt, to get an exact value, that is 250 root 3. And then this is miles per hour. If you want an approximation, so you approximate that 250 times the square root of 3, that is around 433 miles per hour. So what is this answer represent? This answer is the rate of change of the distance, the rate of change of y, when y is equals to 2. All right, so that is the first problem. I will see you in the next problem.